Hello, my dear friends. Welcome to our lecture 2 of this linear algebra course. In our lecture 1, we saw row picture and column picture for for our 2D equations. Now, now we will see it for our 3D equations. So, uh, these 3D equations we will do it using an example. Now, let us take this example. We will see the row picture and column picture for these 3D equations. Let our first equation be x plus y plus z equals to 3. Second is 2x plus 5z equals to 7. Our third will be 3x minus 4y plus 7z equals to 6. So this is our first equation. This is our second equation. This is our third equation. Now we will see the row picture and column picture for these equations. Seeing the row picture is also manageable for the 3D equations, but it is not manageable for 4D or other dimensions. For 1D, 2D and 3D, you can still manage to see the row picture. Now what we will do is we will first see the row picture of the equations. Now representing the equation in 3D, in this 3D form will give us a plane. So let us first form a coordinate system for our x, y and z. So this is our x direction, this is our y direction, this is our z direction. Now we will plot our planes. Our first equation is x plus y plus z equals to 3. Now the 3 points that will lie on this plane that we know are 3 comma 0 comma 0, 0 comma 3 comma 0 and 0 comma 0 comma 3. So what we can do is we can take these 3 points and then we can make a plane that will pass through these 3 points. So this will be a plane that will pass through the equation that will satisfy the equation x plus y plus z equals to 3. Similarly, we can have a plane for our second equation, that is 2x plus 5z equals to 7. Here we don't have any coefficient for y, it is 0 here. So the what this plane will be, it will pass through the y-axis. This plane will pass through nothing but y-axis. So this axis that you see here, y-axis, so it is going to go through this y-axis. This so it will be in the the value of y, we can take any value for y. So 2x plus 5z will satisfy 7 for any value of y. Now let us make this another plane. So this plane will be something like this. So this will be the these are the two planes. Now what we see is that we have an intersection point. So first intersection point is somewhere here, second is here. Now if you draw the planes, they might differ somewhere also. So we can make a line through these planes. So we will have a line. Let me draw it using another color. So this will be a line. So this will pass through our 2 points that are on the plane. So intersection of these two planes will give us a line. So in 3 dimensions, if we have two planes that intersect each other, so they will form a line. Similarly, if we have n dimensions, then n minus 1 dimensions, if they intersect, they will form a line. Now, if we plot our third equation, what we will get is, we will get a point if they intersect. So, if all the three equations intersect, we will get a point. Similarly, for n dimension, if all the n equations intersect, we will get a single point. So this last point will be our answer. Now we saw the row picture. In the row picture, we represented all these three equations in a plane. Now let us see about how do we see our column picture. So let me remove this. We will take this same example for the Gaussian elimination also. Now the thing is that when you draw these three planes in 3D, this will intersect at the point x equals to 1, y equals to 1, and z equals to 1. So you can go to online to any software and plot this three planes, or you can do it by yourself. So what you will get is, you will get an answer that will be x equals to 1, y equals to 1, z equals to 1. Now we will see this. We will see how to get the answers. Now we will see our column picture. So in column picture, what we do is, we take out our variable outside and then we write the coefficients in the form of vector. So it will be x, this will be 1, 2, 3. These are the coefficients of x. Then it will be plus y. First coefficient here is 1, second is 0, third is minus 4, plus z, 1, 5, 7. So this will be equals to 3, 7, 6. So now we have three-dimensional column vectors. We need the right values of x, y, z. We need these right values so that we can get our right hand side vector. So we can do two operations here. Either we multiply vectors by scalar, or we can add the two vectors. So we need some linear combination of this left hand side vectors to give us this particular right hand side, and we know that the linear combination is 1, 1, 1. So when you do these vectors, that is, you put x equals to 1, y equals to 1, z equals to 1, you will definitely get this column vector on the right hand side. So in the column picture, what we do is, we get the right combination of these variables x, y, and z to get this to get our answer. So our goal of linear algebra is to look beyond these three dimensions. So we look beyond the three dimensions, and with n equations and n unknowns, we will have n planes in our row picture. And in column picture, what we will have is, we will have n vectors and a right hand side that we need to get. So we will, so in our row picture, we find the intersection of these planes, and in our column picture we find the right linear combination. So these both are really necessary to get our answers. Now we will see how to solve these equations using the Gaussian elimination method. We now saw row form, we now saw the column form of the 3D equations. Now we will see how to get our answer using the Gaussian elimination method. So these are our three equations. So in Gaussian elimination, what we do is we take this variable, let us this variable is x, and then we remove this variable from equations 2 and 3. Similarly, we will take the variable y from here, and then we will remove it from our equation third. We will get more clarity as we move ahead. So our first goal is to eliminate x from our equation 2 and equation 3. So let us first do that. So our first operation will be we subtract 2 times of row 1 from our second equation. So our operation will be r2 equals to r2 minus 2 times of r1. So it will be 2x plus 5z equals to 7, and this will be 2x plus 2y plus 2z equals to 3 times 2 is 6. So now we reduce it. So what we will get is minus 2y plus 3z equals to 1. So our equation will be minus 2y plus 3z equals to 1. Now our second operation will be this will be done on equation r3. So what we will do is r3 minus, so this to remove this we need 3 times of equation 1, r3 minus 3 r1. So this will be 3x minus 4y plus 7z equals to 6. The other equation will be 3x plus 3y plus 3z equals to 18. Now when you reduce this, what you will get is minus 7y plus 4z equals to minus 3. So we will write it here, minus 7y plus 4z equals to minus 3. So now our three equations that we now have is x plus y plus z equals to 3. This is our, let us say, fourth. This is our fifth. This is our sixth. So our three equations are x plus y plus z equals to 3, minus 2y plus 3z equals to 1, minus 7y plus 4z equals to minus 3. Now we have completed our first stage. That is, we have removed x from row 2 and row 3. Now what we will do is we will remove this y from row 3. So to remove this, what we will do is we will do the operation again. Our new operation will be R3 minus, we take the coefficient here, that is 7 by 2. So what we will do is 7 by 2 times of R2. What we do here is we need to remove y from this. So this will be minus 7 divided by minus 2. So the coefficient that we will have is minus 7 by 2. So we will reduce this from our row 3. This r is nothing but row. So first we will multiply our equation 5 by 7 by 2. So this will be minus 7y plus 21 by 2 z equals to 7 by 2. Now we will do the subtraction. So this is minus 7y plus 4z equals to minus 3, and our this equation 7 by 2 r2 is minus 7y plus 21 by 2z equals to 7 and a half. Now we will subtract these two equations. So this will be plus minus minus. So the subtraction will give us minus 13 by 2z equals to minus 13 over 2. So our new equation is minus 13 by 2 z equals to minus 13 by 2. So let me clear this area. So our new set of equations are x plus y plus z equals to 3 minus 2y plus 3z equals to 1 minus 13 by 2z equals to minus 13 over 2. So let us call this as equation 7, 8 and 9. This is minus 13 by 2. So now we have our set of equations. So we moved from equation 1, 2, 3 to 7, 8 and 9. So this was our elimination procedure. So we eliminated x from equation 2 and 3 and y from equation 3. Now we will solve this set of equations using the bottom up approach. So we solve from the bottom to top. So by solving the equation 9, what we get is z equals to 1. Now what we will do is we will put z equals to 1 into equation 8. So it will be minus 2y plus 3 equals to 1. So this will again give us y equals to 1. Now we will put z equals to 1 and y equals to 1 into equation 7. So this will give us x equals to 1. So now we have the set of solutions, that is x equals to 1, y equals to 1 and z equals to 1. So this method that we did now is known as back substitution. And our coefficients here, that is the first coefficient. So this here is 1, this here is minus 2, this here is minus 13 by 2. These are nothing but the pivots. These pivots, we will see more of them in our upcoming lectures. So in Gaussian elimination, we saw forward elimination and back substitution. Now if you have a valid set of equations, you will have n number of pivots for n equations in a set. Now with all the n pivots, we will have a solution. If a 0 appears at any pivot, our process will stop. So for that case, we will see some of more operations in our upcoming lectures. So in this lecture, let me summarize this for you. So in this lecture, we saw the row picture again. We saw the column picture, and we saw the Gaussian elimination. In our row picture, we drew all the three planes, and then we found that the intersection of these planes will give us a point, and that will be our solution. In column picture, we saw that the linear combination of these vectors need to produce our solution. In the Gaussian elimination part, we saw that we need to remove the variables using forward elimination, and then using back substitution we will solve the set of equations. In Gaussian elimination, you saw about a brief about pivots and how to solve the equations. So in our upcoming lecture, what we will see is what is known as a singular case. So in our upcoming lectures, we will see singular case and matrix notation and multiplication. So that is all in this video that we have. So hope to see you in the next lecture. If you have any doubts, please comment. Our team will be happy to reply to your comments. So that is all in this lecture. Thank you again for watching. Thank you.